Hey, fourth grade. Today we are on Module 7, Lesson 4, and we are going to use these conversion skills that we've been practicing this week, and we'll be using them in word problems. So today our table of contents says M7L4 conversion word problems, and when you are ready, you are going to pause this video to fill in your table of contents, find your next blank pages, and we'll get going together. Fourth grade, today we're going to be solving some word problems using the RDW steps. Sometimes there'll be multi-step word problems, and we're going to be using our customary conversions. And customary conversions can be a number of different conversions that we've practiced this week. It might be the way that we measure weight, how long we measure time, how full we can fill a space, its capacity, and finally how long something is in length. So let's review some of the conversions that you've practiced so far in Module 7. In 1 pound, there are 16 ounces. I remember in the first lesson of this module, I multiplied my number of pounds by 16 to figure out how many ounces they would be. Recently, we've learned about time. When time passes in minutes, seconds, and hours, how can we switch between these units? Starting with minutes. There are 60 minutes in an hour. 60 is kind of a magic number because there's also 60 seconds in 1 minute. Man, I wish we could do a clean sweep and I could say that there's 60 hours in a day, but there are not. There are 24 hours in 1 day. So that means that if we're trying to go from hour to minute, minute to seconds, day to hours, we've got to multiply by that number of that unit. We have to multiply by 60, multiply by 60, multiply by 24. Same goes for our units in ounces. We have to multiply by 16. So I'm going to draw this symbol here to show that if I want to convert it, I take the number I have in my larger unit and I multiply it by this number. Let's go over to capacity. Capacity is how much space we can fill up. Milli was a term that we learned a few modules ago, like in millimeter. Milli means 1,000. So there are 1,000 milliliters in 1 liter. We were also introduced to a new unit, and that was a gallon. Quarts is a familiar word for me. It reminds me of quarters in a dollar, quarters in a football games. And so if I think of the word quarts, the number that pops up in my head is 4. I have 4 quarters in a dollar. There are 4 quarters in a football game. So there are 4 quarts in a gallon. Just like our other units, to convert it, I would take how many I have in the larger unit and multiply by that number. Lastly, length, how long something is. There are 12 inches in a foot, and there are 3 feet in 1 yard. And again, I multiply to get from one number to the next. We also even learned that to get from 1 yard to inches, our largest unit, to our smallest unit, we multiplied by 36 because each yard was 3 feet. And if each foot is 12 inches, 12 times 3 was 36. So now that we've reviewed some of these units, we can work on these word problems. We're going to have one on the first page and one on the second page. If you want to be a beast at a word problem, you have to start off as a cub. Let's read it together. A dishwasher uses 11 liters of water for each cycle. A washing machine uses 5 times as much water as the dishwasher uses for each load. Combined, how many milliliters of water are used for 1 cycle of each machine? Okay, I'm going to circle my numbers first. And already I can see some numbers and units popping up. 11 liters. A washing machine uses 5 times as much water as a dishwasher uses. Combine how many milliliters of water are used for 1 cycle? of each machine. Now I'm going to underline my question. Combined, how many milliliters of water are used for one cycle of each machine? And now I'm going to box important words. I'm noticing that this is going to be a multi-step problem because I've broken it up into step 1 and step 2. But I don't know what operations are going to be in those steps. So I want to find clue words to help me pick out what operations to do. A dishwasher uses 11 liters of water for each cycle. A washing machine uses 5 times as much water as a dishwasher uses for each load. Combined, how many milliliters, that's an important word for me because it tells me what unit my answer is going to be, and that's going to be in milliliters, of water are used for one cycle of each machine. So now I need to figure out, using these clue words, what each of these steps would be for the problem. A dishwasher uses 11 liters of water for each cycle. A washing machine uses 5 times as much water as a dishwasher uses. I know how much a dishwasher uses. It uses 11 liters. I'm going to label this tape diagram with a D. But I don't know the exact amount that the washing machine uses. All I know is that the washing machine is 5 times as much. So it's like running that dishwasher with 11 liters of water 5 times in a row. So for my second tape diagram, I'm going to illustrate that. I'm going to take that same length that I used for my dishwasher, and I'm going to extend it out 5 times and label each 11 liters. And that's going to represent my washing machine. So my step 1 is to figure out how many liters of water does a washing machine use in one load. And to do that, I see that I have 5 groups of 11 liters. So I'll use the operation multiplication for 5 times 11 liters. So in total, a washing machine runs on 55 liters of water. So now we finally know all the information that we need to solve this problem. We know how many liters a dishwasher runs on, how many liters a washing machine runs on, but we need to figure out combined, meaning we might need to do some addition here, how many milliliters of water are used in one cycle of each machine. So now we need to first combine these together and then put our answer into milliliters. I know that a dishwasher runs on 11 liters of water. If I combine that with 55 liters of water, we can figure out how much water both run on with one cycle. 55 plus 11. 5 plus 1 is 6. 5 plus 1 is 6. They use 66 liters of water. But before I end the problem, I need to pay attention to my units here. They want to know how many milliliters of water are used for each cycle. If I look up at my units, I can convert liters to milliliters by multiplying 1,000. So if I take the answer that I got from this number sentence, 66, and I multiply that answer by 1,000, I can get my answer in milliliters. 66 times 1,000. When I multiply with zeros, I start with just the original math fact, 66 times 1. anything times 1 is itself, so 66 times 1 is 66. However many zeros are in my number sentence are however many zeros are in my answer. 1, 2, 3. 1, 2, 3. That's how many milliliters we have. So now we can finally write our statement. Combined, how many milliliters of water are used for one cycle on each machine? The machines on one cycle use 66,000 milliliters of water. Let's try it again with a second problem. Joyce bought 2 pounds of apples. She bought 3 times as many pounds of potatoes as pounds of apples. The melons she bought were 10 ounces lighter than the total weight of the potatoes. How many ounces did the melons weigh? Let's go through and find some boxed important words. Joyce bought 2 pounds of apples. She bought 3 times as many pounds, I should probably box that one since that's a unit, of potatoes as pounds of apples. The melons she bought were 10 ounces lighter. That tells me it's going to weigh less than the total, that's an important word, weight of the potatoes. How many ounces did the melons weigh? So eventually our second step, is to figure out how much those melons weigh. And to figure out how much the melons weigh, let's see what we need to do. The melons she bought were 10 ounces lighter than the total weight of the potatoes. Okay, so to figure out how much the melons weigh, we need to figure out how much the potatoes weigh. So how much did the potatoes weigh? Joyce bought 2 pounds of apples. She bought 3 times as many pounds of potatoes as pounds of apples. So we don't actually know how much she bought in pounds of potatoes. All we know is that she bought 3 times as many as the weight of apples. The weight of the apples was 2 pounds. Remember, we can use LBS as a shortened way of saying pounds. To figure out the potatoes, she had 3 times as many. So we're taking those 2 pounds and we're continuing to repeat it till we have 3 groups of them. So to figure out the potatoes, we've got to do 3 groups of 2 pounds. Well, that's a simple math fact. 3 times 2 pounds equals 6 pounds. The next step tells us that we're going to figure out how much the melons weighed if we subtract 10 ounces. Wait a second. To figure out how much the potatoes weigh, they're 10 ounces lighter than the potatoes. 6 minus 10, I can't do that math fact. The reason why this isn't working is because my units are different. My pounds and my ounces are different units. I can't take away 10 ounces from 6 pounds. My first step is that I need to change these 6 pounds over into ounces. I'm going to take 6 pounds and I'm going to multiply it by 16 because there are 16 ounces in every pound. So 6 pounds would be 6 groups of 16. Once I figure that out, then I can take away my 10 ounces to find the total weight of the melons. So let's start with the multiplication of the ounces. 6 times 16. I'm going to set up a standard algorithm. Six times 6 equals 36. 6 times 1 equals 6, plus 3 more equals 96. Okay, so the total weight of potatoes in ounces is 96 ounces. Now I have enough to take 10 away. 96 ounces minus 10 ounces. 6 take away 0 is 6. 9 take away 1 is 8. So I'm left with 86 ounces. The question's asking, how many ounces did the melons weigh? The melons weighed 86 ounces, period. Those are our 2 problems we've practiced with today, and I've got some good news for you. The problems you've just done are actually much easier than the ones you're going to see on your problem set or even your exit ticket. There might be a few multi-step problems, but really we're just focusing on how to convert and solve word problems. So now it's your turn. Good luck on that problem set.